And if you increase the resistance, what happens to the current? Current must decrease, because resistance means what? It is opposition to the flow of electrical charges, right? If you are increasing that opposition, current must decrease, right? Flow of electrical charges will be opposed. So that is what it decreases, current decreases. Next, what happens if you decrease the voltage? What happens? Resistance will be constant, but current will also decrease, because voltage if you increase, current will increase. Voltage if you decrease, current will also decrease, but resistance will be same. Dear students, in today's class we are going to learn one of the most important concept of your class 10th science, that is from electricity, that is Ohm's law, right? Here, most of students they find it difficult to present uh, or solve the problems based on this, because they will be lacking the basics related to that Ohm's law. First, if you want to understand Ohm's law, you need to understand what is electric charge, how to measure the amount of charge, what is electric current, what is electric potential, what are the devices used to measure them, what are their SI units. All these things, if you are very much clear, only then you can understand, right? So only then you can solve the problems based on that. This is very much basic concept of your class 10th entire electricity, right? So now we will try to understand only Ohm's law. I'm not going to the basics. If you need, you can ask me in the comments so that I can take up that also. Now coming to here, first Ohm's law. Let us try to understand, try to analyze this, right? What it says, before coming to Ohm's law, let us try to understand here. Two electrical circuits are given here. This is called schematic diagram. This is called what? Real one. Okay. In real one, we are not using everywhere. We are using this schematic diagram in order to show each electrical component. Say, for example, here symbols we have used to show these, what battery it may be or resistor it may be. But everywhere we cannot draw these exact pictures. That is why we are using these schematic diagrams. Here in the real diagram, what it is shown here, resistor, it is looking like this, right? With color codes it is shown. Here this is battery, here means cell it is used. Here one ammeter is used here, right? So this, let us try to understand what Ohm's law states. In your textbook it is mentioned, what they have given here, Ohm's law states that in an electric circuit, means for example, the potential difference across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided the temperature remains the same. It is given, right? This is mentioned in the textbook. Here, if you come to know that through the circuit diagram, here what happens? This is resistor here, okay? Resistor. Here, one end, the other end of these two terminals of this cell, they are connected to two ends of this resistor, right? Now, what it says, the potential difference is applied from the cell. This potential difference is means across the ends of this resistor is directly proportional to the current flowing through it. How much current it is flowing? 0.30, right? It is directly proportional. Means what? If you increase the potential difference by applying another cell, then current will double, right? So as you go on increasing, here potential difference, current will also increase. So this relation, we can say that P is what? Directly proportional to I. Okay, here P is directly proportional to I. If you increase the potential difference, current will also increase. Okay, this P upon I, if you take the ratio at every point, okay, you are going to get constant. Okay, that constant we are calling it as what? Resistance. Okay, here when we write that in the expression form, P is equal to IR we are getting, because if you divide this P by I, you are getting that constant. That constant is nothing but resistance. What is resistance? Resistance is nothing but what? It is the opposition offered to the flow of electrical charges in a conductor. Say for example, if it is a conductor, if the electricity is passing through this, it will have some opposition. Electrical charges, they do not flow easily. They have some opposition. That opposition we are calling it as what? Resistance. Remember, right? Here, next, one more thing what they have mentioned is, provided the temperature remains the same, means temperature should not change, only then this is applicable. So what we can say here, this is applicable only for means ohmic conductors, Ohm's law, right? Ohmic conductors, there are different types of conductors. If it is required, we'll discuss in another video based on that. Okay, ohmic and non-ohmic conductors. Here, coming to here, of here, that is already mentioned, what statements we have already told. This is what? Triangle of Ohm's law. If you take this in simple way, we can get three expressions from this single expression here. What it is given here, P is equal to IR. Here three different expressions we are getting. This is very much important. Okay, so what happens here? P is equal to I into R, I is equal to P by R. R is equal to V by. How? Here you can see V by R. See V by I. V upon I if you take R, you will get. V upon R if you take I, you will get. And if you multiply these both together, you are going to get V, right? This triangle, if you remember, means all the three expressions you can get from that. Next, coming to here practically if you check what happens. Here voltage, resistance and current are given, right? If you increase the voltage, current should also increase and resistance will be constant. It does not change, right? So you can check here. Next, coming to here, next voltage if you keep constant, okay, and if you increase the resistance, what happens to the current? Current must decrease because resistance means what? It is opposition to the flow of electrical charges, right? If you are increasing that opposition, current must decrease, right? Flow of electrical charges will be opposed. So that is what it decreases, current decreases. Next, what happens if you decrease the voltage? What happens? Resistance will be constant, but current will also decrease because voltage if you increase, current will increase. Voltage if you decrease, current will also decrease, but resistance will be same. That does not change. So this is what practically when you check. So that is why what we can say: more voltage, more current; less voltage, less current, right? So means this is based on what we have derived here. This will be equal to IR. Here some of the key points here, where it is used here, okay, that is given here. Ohm's law in designing electrical appliances, it may be some heater coils or what resistors. Wherever we are using any electrical appliances, there we are using this. Next, electronics and electrical devices and measuring unknown, means these types of devices you might have seen, there also they are using this Ohm's law, right? Here some key points are given here. This also you can check it once. Here what? At constant temperature means constant temperature only, then P will be directly proportional to I. Next, coming to here, if phi is constant, I is inversely proportional to R, means current decreases as the resistance increases. Right. Next, if R is constant, then I is directly proportional to V. Means as you increase the current, potential difference will also increase. Means both are related to directly proportional there. Next, coming to unit. Okay. What is this? Here maybe this is not clear. You can see here. Now unit check. There 1 volt means what? How we are getting V equal to I into R or not? I is measured in terms of ampere, right? Next R in ohm. So that is why what we can say here, 1 ampere into 1 ohm gives 1 volt. Okay. Or if you want 1 ohm is nothing but R equal to V by I or not. So 1 volt upon 1 ampere. Remember. So this law is valid only for ohmic conductors. Okay. So this is how we can say that this is what Ohm's law, right? In short, if you have understood clear concepts of that, basics of this Ohm's law, means that such as electric current and potential difference and so on, then it will be very much clear to you. You can solve any type of problems which are given based on these expressions, right? In the next video, we'll go ahead with other topics which are most important from this electricity part. If you find any topic difficult from this chapter, you can comment. I'll pick up that topic.